Let's look at factorization of polynomials. To start with, if we look at a polynomial x cubed minus 23x squared plus 142x minus 120 and write it as an algebraic expression. If we had to factorize this polynomial, how do we go about it? So first look at the factors of this constant term minus 120, and we can see that it has factors such as plus minus 1, plus minus 2, plus minus 3, and so on. So if we found the value of p of 1, it would be 1 minus 23 plus 142 minus 120, which upon calculation is equal to 0. Therefore, x minus 1 is a factor of p of x. So we are saying that, hey, p of x can be written as x minus 1 multiplied by certain x of x, where s of x is also a polynomial. Now, what is s of x? So in what we need to do is find a way of splitting p of x such that x minus 1 can be taken out as a common factor. So we know that p of x is equal to x cubed minus 23x squared plus 142x minus 120. Here, let's break 23x squared as x squared minus 22x squared, because this second term has been split into minus x squared and minus 22x squared. Let's try and break 142x as minus 122 as well. So here we would get 22x plus 120x minus 120. So we get x square x minus 1 by taking x square common out of x cube minus x square, minus 22x is common here, so x minus 1, plus 120 is common here, so x minus 1. And here we take out x minus 1 as a common factor out of all three terms. So you get s of x, which is x square minus 22x plus 120. Right? So this is what is s of x. We can further split s of x using similar methodology. We've already defined root of a polynomial or 0 of a polynomial. So 0 of a polynomial p of x is a, where p of a is equal to 0. This is another way of saying that, hey, x minus a is a factor of p of x if p of a is equal to 0. The other way of saying it is also true, which means that if x minus a is a factor of p of x, then p of a is equal to 0. It's just a relationship between p of a equal to 0 and x minus a is factor of p of x. It just works both ways, right? So if one is true, the other becomes true, and if the other one is true, the first one becomes true. We'll look at this factor theorem and understand how factorization of polynomials works. Let's look at example 6 from textbook. It asks us to examine whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 and of 2x plus 4. This question states two polynomials p of x cube plus 3x square plus 5x plus 6 as well as a q of x which is 2x plus 4. And the problem is asking us to check if x plus 2 is a factor of these two polynomials. So we'd simply replace or find the value of p of minus 2. This is minus 8 plus 12 minus 10 plus 6, 0. Similarly, we'll use this operation for q of x, 2 into minus 2 plus 4, which is minus 4 plus 4 equal to 0. Therefore, x plus 2 is a factor of both p of x and q of x. Let's look at example 7. It is asking us to find value of k if x minus 1 is a factor of the mentioned polynomial. So what it is telling us is that if x is equal to 1, then p of 1 is equal to 0, which means 4 of 1 cube plus 3 of 1 square minus 4 of 1 plus k is equal to 0. This is a simple equation. We can solve it. 4 plus 3 minus 4 plus k is equal to 0, and hence k is equal to minus 3. Let's factorize polynomials by splitting the middle term. If we denoted a polynomial x squared plus lx plus m in the form of two of its factors x plus a multiplied by x plus b, it basically means that x square plus ax plus bx plus ab, which also means that x square plus a plus bx plus ab. So if we equated the coefficients of terms from both the sides, we would get L is equal to a plus b and m is equal to ab. Generally speaking, if the polynomial was denoted as ax square plus bx plus c is equal to p of x plus q multiplied by rx plus s, where these two terms are the factors of polynomial p of x, then when we multiply these two factors, we would get pr of x square plus psx plus qrx plus qs, which can also be denoted as pr of x square plus ps plus qr in the bracket of x plus q of s. Equating the coefficients on the two sides, we get a is equal to pr, b is equal to ps plus qr, and c is equal to qs. If you had the value of some of these uh, constants, that is a, p, r, b, c, etc., you can find the missing value.